Hello, Sas here. I'm going to introduce what we call a system. But before I do, we need to make sure that we understand what it means to have a solution. The definition of solution in math is a value for a variable that makes the equation true. What do we mean by that? Let's give an example. We could be asked to solve. And what would we be asked to solve? Maybe an equation like 10 is equal to 2 times x. Now it's understandable that when asked to solve, many people think produce an answer. But solve means something precise and specific. It means to find a value for the variable, in this case x, that makes the overall equation true. Now, you wouldn't have a solution x is equal to 3. 3 is not the solution to this equation. We can check because if x is equal to 3, then 2 times 3 is 6, and 6 is not equal to 10. So what value of x makes this equation true? We don't have to guess, even though we might be able to. We can use the algebraic process to undo what's happening to x so that x is by itself. And on the other side of the equation, we can simplify this to 5. The value 5, if substituted in for x, will make the original equation true. We say x equals 5 is the solution. So, what's a system? A system, in various simplest terms, means more than one equation. This example here was not an example of a system because it was only one equation that we started with. Let's give an example of a system. We could be asked to solve, but what we start with is not just one equation, but more than one. I'm going to write a second equation, y equals 3 times x minus 5. And typically, if we have a system of equations that are meant to be solved together, then we would join them by a bracket. And this bracket is grouping these two equations. So we have a system here. It's more than one equation. What does it mean to solve it? Well, it means that we need to use algebra to find values for all the variables that make all of the equations in the system true. If we take a look at the variables in the system, there are two, x and y. And so to find a solution means to find both a value for x and a value for y that makes both equations true when I substitute them in. So we could update what we define as solution, because if we can solve a solution, it means that we are finding values for all variables that make all equations true. I updated my definition of solution to include an understanding that we can have more than one equation. So how do you do that? Well, this equation here only has one variable in it, and I know from previous work that when I solve for x, then I get x is equal to 5. If I take this first equation and solve it for x, I get x equals 5. But x equals 5 is only part of what this second equation needs to be solved. I still need to find a value for y. And how I'm going to find that is I'm going to take the second equation and I'm going to rewrite it, but I'm going to substitute in the value 5 that I've already found for x. And when I do, I can get y already by itself. Simplify the other side. 3 times 5 is 15, and then 15 minus 5 is 10. I found a value for y and x. And if I put these values in to both equations, I can show that the equations will be true. So the solution to this system is x equals 5 and y equals 10. I can express the solution by circling those values. I can also make them a point as an ordered pair, x, y, that we typically graph. I could put the x first and the y second, and I could express the solution of both those numbers at the same time like that. Let's do this one more time. If I was given the equation y is equal to 3 times x, and a second equation y is equal to 2x plus 8, and I joined these equations and grouped them to think of them as together, then this is a system, and I could be asked to solve this system, which means that I need a value for x and y that make both these equations true. Well, how am I going to find that? There are many techniques to solve systems. The technique that I'm going to use right here, because they're both solved for y, is to think like this. If y is equal to 3x and y is equal to 2x plus 8, then 3x and 2x plus 8 must be equal to each other. I'm going to say that reasoning again in another way. If these two expressions are equal to the same thing y, then they must be equal to each other. So I can rewrite these two equations. I can set 3x is equal to 2x plus 8. Only because these two expressions are equal to the same thing. Another way to think of that is I substituted the 3x in for y in this equation. And when I did, I rewrote it, and I noticed that there's only one variable in this rewriting of this equation. It's x. So I can use algebra to find x. I'm going to do that. I'm going to subtract 2x from both sides. When I do, the 8 is left on this side. 3x minus 2x is 1x. And already in one step, I know the value of x. It's 8. But this is not a solution to the system, because to find a solution, I'll also need to find y. How am I going to do that? I'm going to take the first equation, y is equal to 3x, and I'm going to rewrite it. But when I do, since I found the value of x to be 8, I can substitute that value in for x. And when I've done that, I've rewritten the equation, but only y is unknown, and I can quickly find that out. 3 times 8 is 24. I have a value for y. And now that I have a value for both x and y, which are all the variables in my system, I've solved the system. The solution to this system is x equals 8 and y equals 24. I could check that by substituting 8 in for x, and confirming that 2 times 8 plus 8 is equal to 24. The solution can be expressed as a point where x comes first and y comes second.